In this lesson, we'll be looking at annuities and we'll be investigating both algebraic and graphics calculator solutions. So an annuity is a series of payments made at fixed intervals of time. We'll be looking at two main types of annuities, so a future value of an ordinary annuity. So in this situation, you're depositing money at regular periods to purchase something in the future. And the amount you accumulate will be the sum of the deposits plus the interest that you earn along the way. Some people remember this as S for saving because you're saving towards some future goal. The present value of an annuity, in this situation you'll start with a large sum of money which is generally paid down to zero or amortized with regular payments, and there are two common examples. The first one being a mortgage, where you start with a large sum of money that you borrow from the bank and you pay it off with regular payments. And the second type, where you buy an annuity from the bank in order to live off a set amount of money per week or per month. So often when people are retiring, they may buy an annuity to give them a regular income. So an example, Kylie's been making periodic payments into an account. How much will she have after 10 years if she's depositing $200 at the end of each month and she's earning 8% per annum compounding monthly? So she's making regular payments towards some savings goal, so we'll use the future value of an ordinary annuity. Note that the interest rate is obviously 0.08 over 12 because interest is compounding monthly. So algebraically, we start with our formula, we substitute in those values, and we end up with $36,589.21. Now note, she's only deposited $24,000, so $200 a month for 10 years, and yet she'll accumulate $36,589. The difference between those amounts is the interest that she has earned. We can also solve it using the TVM Solver on our graphics calculator. So now we're going to use our graphics calculator to perform the same calculation. We go to Apps, Finance, TVM Solver. The number of payment periods that we have is 120, 12 months by 10 years. The interest rate is 8%, which we put in as 8, not 0.08. The present value of our annuity is 0. We haven't started putting money in yet. The payment is going to be $200 per month, and so we put negative 200. The reason for that is anytime we're giving money to the bank or to the financial institution, as far as we're concerned, it's a negative value. Anytime we receive money back from the bank, we should expect a positive value. Future value is what we want to calculate. We'll leave that for the minute. Our payments per year is 12, and our compounding periods for interest is 12 per year, once every month. So in order to work out the future value, we scroll to the future value position and we hit alpha solve, and we get $36,589, which is the same as what we obtained using our algebraic method. Notice it's a positive value because at the end of the period, when we've deposited all our money and accumulated interest, we will get back from the bank $36,589. Now, a different example. Pauline has recently retired. She wants to set up an annuity that will pay $1,000 at the end of each month for the next 20 years, and she's earning 9% interest compounded monthly. How much is it going to cost to buy this annuity? So she's buying the annuity now, and she'll amortize it over time. So we're going to use the present value of an annuity formula. So algebraically, we use our formula, we substitute in our values, and we end up with $111,114. Now note that she's getting a total of $240,000 over 20 years. Those regular payments will add up to $240,000, and yet she's only paying $111,114 for the annuity. The rest is the interest that she's earning on any remaining money in the account at any given time. To solve this problem using our TVM Solver, we go to Apps, open TVM Solver. The N is 240 because we're paying monthly, or going to be paid monthly over a period of 20 years. The interest rate is 9%. The payment is $1,000, and it's a positive value because Pauline will be receiving $1,000 from the bank every month. The future value is 0 because we're going to work this annuity down to 0 over the 20-year period, and there are 12 payments per year and 12 compounding cycles per year, because it's monthly. And the present value is what we want to determine. How much is this going to cost Pauline now? So we put the cursor in the present value position and we choose alpha solve. and we get $111,144 as we did algebraically. Notice it's a negative value because Pauline will have to give that amount of money to the bank in order to buy this annuity.